9.6 practice problems. Two students prepared aqueous solutions of lithium chloride and measured the properties as shown in the table above. Both students observed that solid lithium chloride readily dissolved in water. The students drew particle diagrams explaining the changes in enthalpy and entropy as a dissolution of lithium chloride based off of their results and observations. Based on this information, the better particle diagram was shown by which student, and why is that diagram more accurate? So as we look at student 1's diagram, we can see a complete dissociation between lithium and chlorine, which is what would happen when lithium chloride dissolves, since it is an ionic compound, and we do see a ready dissolution. Whereas student 2 does not have them dissociating at all. So student 1 is definitely going to be the better diagram, and so I am going to go ahead and eliminate any answer choice that says that student 2's diagram is better. And then next up, I'm going to go ahead and evaluate between answer choices A and B to see which one is better. So A says that the better particle diagram was drawn by student 1 because the lithium chloride dissolves in water. It dissociates to lithium and chloride ions, causing an increase in entropy. That is going to be correct. We do see that our overall situation, we are producing more individual molecules throughout the thing, so we are increasing entropy. And then we can also see that we have an increase in our initial temperature there as well. Option choice B says that the better particle diagram is shown by student 1 because the lithium chloride dissolves in water. It dissociates into lithium and chloride ions, indicating that the dissolution of lithium chloride is exothermic. So the diagram actually does not show me that this is going to be exothermic. So my entropy would be shown by the diagram, increasing the overall number of molecules present, but my temperature is not actually, like, I do have a thermometer represented here, but it doesn't show me like initial versus final or anything like that. So my exothermic nature of this dissolution is not represented by the diagram, and so that is not going to be my answer choice. The table above lists the equilibrium constants and changes in thermodynamic properties for the dissolution of iron 2 carbonate and manganese to carbonate at 25 degrees Celsius. The two particle diagrams opposite represent saturated solutions of each compound at equilibrium. Which of the following explains which of the properties listed in the table is best represented by the diagram? So here we have our KSP. This is going to be how readily we are going to be dissolving. We have our delta S and our delta H present there. Then we have the two saturated solutions present. We have the iron here, and we have the manganese here. So looking at these two saturated solutions, our overall like the differences between these two diagrams here, I can see that I have a grand total of 1, 2, 3, 4, 5, 6 versus 1, 2, 3, 4, 5 of the carbonates present. And so I do see an increase in the KSP represented by the diagram, just based off of like how much is actually within the solution, how much is actually like up and dissolved. So looking through these options here, option choice A says that the particle diagram best represents that delta H is less than 0 because the ions for both compounds are solvated by the water molecules. That's not going to, I mean, like, yes, but no. Like, overall, this is going to be, like, really impacted by whether we're endothermic or exothermic. So, like, are we seeing ions? Yes. Are we seeing that the delta H is going to be less than 0? No, we don't actually have any information that's going to tell us if this is endothermic or exothermic, so that's not a great answer choice. B says the particle diagrams represent that delta H is going to be less than 0 because both compounds produce the same amount of carbonate from dissociation. So that is very much not going to be helpful here. Yes, both of the cations do have the same charge, so proportionally they're going to release the same number of carbonates, but we did also see that we had more carbonates present here just because the KSP for the iron was larger, and so it is going to dissolve more. Option choice C says the particle diagrams best represent that the entropy is going to be greater than 0 because both compounds produce a very small amount of ions from dissociation or dissolution. So our delta S is going to be greater than 0. We are increasing the entropy, but this explanation about how it's because we have a very small amount that is dissolving is a bad argument for entropy increasing. The greater the amount of ions that are produced, the larger that delta S is going to be. And so just delta S being greater than 0 because of a small amount, that doesn't make any sense. So that's not going to be our answer choice. And then D says the particle diagrams best represent that the molar solubility is greater for the iron 2 carbonate versus the manganese carbonate. So that is definitely going to be true. We do have a difference between these two diagrams where we are seeing that the overall dissolution rate for the iron is higher than that for the manganese. So option choice D is going to be my answer choice. High solubility of an ionic solid in water is favored by which of the following conditions? So the condition in which we are going to really like dissolving away an ionic solid is definitely going to be entropy for sure. So option C says that we are increasing entropy. So any answer choice that does not include an increase in entropy, I'm going to go ahead and immediately eliminate it because the dissolution and the making of more individual ions is definitely a strong reason that the solution favorability would be there. Okay, so then we're going to go ahead and see why it would be favored. Option choice 1 says the existence of strong ionic attractions in the crystal lattice. So this would be why we would really not want to dissolve. So I'm going to go ahead and get rid of option choices C and E. And then number 2 says the formation of strong ion dipole attractions. We are going to see those present between the dissolved ions and the water molecule, and that those attractions would be favored, would be present, and would be a thing that we would definitely see as a reason for something to dissolve. So option D, where we are stating that 2 and 3 are good answer choices, is going to be my final answer. At 298 Kelvin, ammonium nitrate readily dissolves in water, suggesting that the change in free energy, delta G, favors the dissolution process. However, when ammonium nitrate dissolves in water, the temperature of the water decreases. The particulate diagram above attempts to provide a microscopic view of the dissolution of ammonium nitrate, considering both that the change in enthalpy, delta H, and the change in entropy, delta S. Which of the following explains what the particle diagram is able to illustrate and why? So we are going to be an endothermic process. And so that means that my overall enthalpy is going to be positive. And then my entropy is still going to also be positive because I am increasing the overall number of ions that is present. So looking throughout my answer choices, option A says that the particle diagram is able to illustrate that delta H for the dissolution is exothermic. We know that that is very much not true. We also don't see any temperature readings here. This is going to be an endothermic process, and so that's immediately eliminated, and then the lack of a thermometer is going to exclude any real way for us to see if it was endothermic or exothermic based off the diagram exclusively. Option choice B says the particle diagram is able to illustrate that delta H, or the dissolution of ammonium nitrate, is an endothermic process. Again, we don't have a thermometer, so that's not going to be a great answer choice. This is endothermic, so that is correct. It is an endothermic process. However, again, this diagram does not show that because we don't have a thermometer present. Option choice C says the particle diagram is able to illustrate that entropy increases when ammonium nitrate dissolves in water because of the ions dispersing in the solution. So we do see an increase in entropy, so that is true. But we're going to go ahead and look at option choice D to see if that one is any better. And then D says the particle diagram is able to illustrate that the entropy decreases when ammonium nitrate dissolves in water because of how many hydrogen bonds can form between water molecules and the ions. That is definitely not going to be true. We have an increased number of overall particles present, and so our entropy is going to increase. So answer choice C is going to be our best answer choice. We see an increase in entropy, and that is represented by the diagram.